We are using Task Parallel library for building concurrent applications. Starting from this tutorial, I'm going to cover every aspect of Task Parallel library. For that reason, I'm planning to have series of tutorials related to TPL. And in this tutorial, especially, we are going to cover Task Parallel library itself. I will provide comprehensive introduction that will help you to understand Task Parallel library. I will talk about thread pool, Task Parallel library in general, and you will understand what are the reasons for choosing one over other. And I will provide some code examples to help you to understand how it is possible for us to create and run tasks. And at the end, we will learn the differences between Task.Run, new task, and Task.Factory.StartNew that are going to be our really important and mostly used task creation techniques. Let's first try to cover what is Task Parallel Library, TPL in short. Task Parallel Library is a high-level API for concurrency. Concurrency is a really important concept here. If you want to cover Task Parallel Library to understand it in more detail, of course, you need to understand concurrency concept and the terminology around this concurrency. Just check my concurrency tutorial to learn every aspect of concurrency. But in general, we are talking about parallel, asynchronous, and multi-thread applications when we talk about concurrency. And Task Parallel Library helps us in an easy manner, in a simple and more intuitive way to create concurrent applications. Task Parallel Library encapsulates some logics like thread allocation and scheduling, and in this way, it helps us to focus directly to our tasks rather than technical details. So Task Parallel library is a wrapper over this type of complex stuff, and every task is a unit of work. This is really important. Every task encapsulates operations that can run in a concurrent manner or asynchronous manner. Actually, when I say concurrent, I mean parallel and multi-threaded manner. For the task, the system may use or may not use threads. If our application is parallel or multi-thread applications, then it will require a thread. If it is asynchronous application, it will not require a thread. This is how it looks like from the .NET perspective. To implement concurrency, we have different types of APIs. First, in .NET 1, we have thread class. Using the thread class, it is possible for us to implement multi-thread applications. We have control over thread to run it, to do additional operations related to thread. But thread by itself is a technical item, okay? This is a technical implementation in .NET platform. So starting from .NET 2, Microsoft tried to isolate us from thread itself and to focus to tasks rather than thread. For that reason, they have implemented thread pool. Thread pool is a wrapper over thread, and we are dealing with the exact tasks rather than thread. But starting from .NET 4, we have Task Parallel Library. Task Parallel Library is not just a wrapper over thread pool. So you can't say that the Task Parallel Library is a strictly wrapper over thread pool, because Task Parallel Library may use, for example, in Task Parallel Library, we have tasks, and these tasks may use thread or not. When we are using thread, we are actually calling thread pool. When we are not using thread, for example, for asynchronous programming, we are using our computer's input-output based asynchronous devices capabilities, okay? So the Task Parallel library is not strictly a wrapper over thread pool. The Task Parallel library pushes us to work with tasks, to focus on tasks rather than threads. We shouldn't focus on technical implementation. We should focus to our exact tasks. So this is really important when we deal with Task Parallel library. So a long story short, Task Parallel library may use thread or may not use. For the asynchronous programming, we are not using thread. For the multi-thread and parallel programming, we are using thread, and this thread will call our thread pool to get and execute a thread from there. Great, now it is time to practice. Here we have the CodeByte solution in our GitHub repo. Just find tutorial Task Parallel Library Part 1 and you will get all the source code. Now let's create a new project here. I'm going to create a simple console application to show you everything related to tasks in practice. Okay, let's create it using .NET 8. It is okay. Don't use top level statements. Yep, cool. Now we have a template console application here. What I'm going to do, I will show you the different ways of creating a task. That is the simplest one, and actually is not recommended one, is going to be our task, my task equal to new task version. It is possible for us to create task using multiple syntax. One of them is actually our tasks constructor, the other one Task.Factory.StartNew, and also Task.Run. I will show you all these possible ways to create a task. For now, we'll focus in new task syntax. I will show you when to use and when not to use this syntax to create a task. For make things really simple, I'm starting with task because this is similar like a thread. If you have knowledge related to thread, you already know that we have constructor based action and func delegate running through the task, running through the thread. So in this case, when you instantiate your task, it requires some action. We have 8 overload for our constructor. Let me show you one of them. This is my simple action, and you are providing some task here to run, for example, CPU intensive operation, and to make it scheduled, just call task.start. That's how we are creating our task. Okay, this is of course the action based. It is possible for us to configure delegate based, the other delegate based like func based implementation. Let's call it my task to equal to new task, and as you can see from the IntelliSense, we have tasks generic version. Let's provide it. For example, let's provide a decimal here, and now it will require func delegate. You can provide any complex type, any primitive type here. It doesn't matter, depending from your requirements. You can provide anything you want. So we have func version, and also here we have some additional configuration regarding to the task. For example, you can configure cancellation token. We'll learn it in more detail. Task creation options. We have the func plus state. Of course, we'll provide it, and the cancellation token, task creation options together. And that's actually all. For the task start new, we have special type of additional argument, task scheduler, but for now let's focus to our task creation. What I am going to do, I just want to provide this func implementation here. Let's try to simulate blocking synchronous operation here, and let's return some value. Okay, that's how we are configuring our action-based task and func-based task. Of course, without lambda expression, you can do it using anonymous functions, even using your direct delegates. You can provide here direct action delegate, direct func delegate. Okay, but the important thing here is this is just a construction process. It will not run your task. If you want your task to be runnable, you should call start method. This is really important. Okay, let's do a little bit real world task here. Okay, I'm just going to comment all these elements here. What I want to do, for example, we may use CPU intensive operations for special type of tasks. For example, if you, let's say you are building Photoshop type of application and you need to get image and apply some filters, and these filters is actually the time consuming a complex operation, so they are actually CPU intensive operations. So you can use task class here to implement this functionality. Let me show you one example. Task, for my task, let's say I'm working with bitmap. Okay, this is my image process bitmap equal to new task bitmap. Let's create this bitmap here, generate a class. It doesn't matter for now. Let's provide for the bitmap. Let's just, for the simplicity, let's provide some name here. Doesn't matter for now. For the task, we should take some data and process it. Okay, let's do it in this way. Let's do it this way. String image equal my image.png. Let's say this is our PNG file, and I want to process it. Okay, return apply filters to this image. Let's say it is our image path, and we are providing it like this. Okay, let's generate this method here. Cool. And voila, this is our apply filters functionality. Of course, from the object-oriented programming, it is not a correct way of implementing it, but for now we are focusing on our tasks. So let's do in this way. It requires some blocking synchronous operation here. Okay, and let's return some new bitmap, and for the name, random generated name. I think that should be enough. Okay, and to run this task, actually we need to start it. That's how we are starting our task. Let me run this application, but before that, I'm just adding read line here. I will show you one example. So we are preparing our task here. That is a CPU intensive operation. It requires our image to apply some filters. Okay, and we will start it. This is a construction process. This is a start process. We have hello world, and we have read line here. In this case, when I run this application, I will see hello world first. Okay, let's do it in this way. Apply and console write line processing is done. Filter applying is done. Okay, apply filter. Let's say we have used this image path. It doesn't matter. Let's just run it. We'll see first our hello world, and after some time, processing is done. We'll pair. Okay, that's how we are running CPU intensive applications using Task.Run. Cool. Let me tell you some more practical cases for CPU intensive tasks. Okay, this is our one example. Let's say you are building Photoshop type of applications. You want to apply some filters. You want to do some additional complex cropping, rotating type of operations. You can use the task here for your images. For your videos, let's say you're using the compression type of stuff, encoding stuff. Of course, you can use tasks here. We have tons of examples. For example, for the text, you can apply serialization, I don't know, encryption, doesn't matter. It should be just a complex application, complex logic to move it to the task itself. Okay. Well, this is our simple example here. We are doing a bitmap processing and we are starting this process. As you can see, it takes some time for application to start, for the task to be started, and we'll see first hello world, and after some time we'll see processing is done. Cool. Let's explain more about this task here, when you should use this task. Actually, I don't prefer to instantiate a task in this way. This is a little bit problematic. In .NET, we have a better version of new task. It is actually Task.Factory.StartNew. Okay, but if you have some advanced cases, let's say when we are using these tasks, if you have some advanced case, let's say I need to create my special task that is inherited from the task. This is really complex case. I don't think that you will require it, but anyway, let me explain this. If you need to inherit from your task, then you should prefer using the new task, and it is stored version. Okay, because otherwise there is no way for you to start your task to inherit from your task if you are not using this type of syntax, if we don't have the new task version. Okay, this is the one version of using my task. Cool. The other important case here is it is possible for us to raise condition stuff related to this task, but let me explain first Task.Factory.StartNew, and let's face with this issue and then compare new task syntax with Task.Factory.StartNew. Of course, Task provides a lot of interesting features to schedule and construct a task, but the better option working with a task is our Task.Factory.StartNew. So we have Task.Factory.StartNew, that is recommended usage rather than the task constructor. So what we are going to do, I'm just going to replace a constructor of this task to change it to work with generic stuff, and that's all. The one thing here is there is no need to type start. Behind the scenes, this mechanism uses factory design pattern and schedules automatically your task. So there is no need to start a task. Task is already started. To handle it, we will use await our process bitmap, and let's make it from void to task. That's how we are working with Task.Factory.StartNew. Why Task.Factory.StartNew is better than task constructor? The first is Task.Factory.StartNew is effective rather than efficient, rather than a task constructor. In task constructor, you have 2 steps to schedule a task. For your first, you are constructing your task, and then you are scheduling it. But when you use Task.Factory.StartNew, you are constructing and scheduling your task 2 in 1. Okay, this is more efficient. In most cases, there is no need to construct your task using new task. Just use Task.Factory.StartNew. Okay. The other problem here is when you use a task constructor, like a new task here. Let's see. In our case, we need to use this start. The problem here is it is possible in some cases for multi-thread environment to reach to this start functionality from multiple threads. So we need to handle synchronization process, in this case manual. Okay, so we have synchronization issue. Of course, for this start we need to be sure that the task will be scheduled only once, and you need to handle all this sort of synchronization stuff and all the related configuration based to synchronization. But when you use your Task.Factory.StartNew, it is automatically constructs and starts your task. There is no need to sync on synchronization. Okay, the second stuff here is 2 steps versus 1 step. In Task.Factory.StartNew, we are constructing and scheduling. For the new constructor, we are constructing and scheduling them separately. So we have 2 operations here, 1 operation for Task.Factory.StartNew. In the Task.Factory.StartNew, there is no need to sync on synchronization context. Okay, there is no need to synchronization context. Actually costs a lot in this case. So Task.Factory.StartNew helps us to not to deal with this issue. For me, Task.Factory.StartNew is always better option rather than new task, because we have efficiency, we have 1 step rather than 2 steps, we are avoiding synchronization context, we are not dealing with synchronization context. But there is some use cases for new task syntax also. Okay, so in some cases, new task is better than Task.Factory.StartNew, but these use cases are a little bit advanced use cases. So in most cases, try to focus Task.Factory.StartNew rather than new task. Okay, let me show you when the new task version is better. We talked the first version about it. When you inherit from the task, you need to use a new task syntax because you are inheriting from the task, and you need to schedule it using tasks instance.start method. The other option here is a race condition stuff. Race condition. Let's talk about this race condition. I'm just using the task, okay, Factory.StartNew. For the Task.Factory.StartNew, I just want to first instantiate it with null, my task equal to null. Okay, let's just copy this, paste it here, comment it out, use my task. Okay, for the my task, what I want to do, I just want to continue. This is all, of course, a special case. I want to continue inside my task with the given instance. So I have start new, but I want to continue. Let's just remove this one here. Okay, continue with, let's just copy here. We have my next operation. Doesn't matter what it is doing here. This is just a sample. Okay, and that's actually all. Let's see what can happen in this case. In this case, it is possible to my task be null because the thread pool may take this operation before the start new returns and the actual instance of a task. Then it is going to be a buggy code here. And this is our race condition problem. And to fix this race condition, you may use just my task and, of course, my task.start. This will never raise the race condition problem here. So we will always get an exact value for my task. So far, we talked about new task syntax and Task.Factory.StartNew. Of course, we have more options to create a task, and one of them is going to be our Task.Run functionality. So we have Task.Run instead of Task.Factory.StartNew. So does it mean that you shouldn't use Task.Factory.StartNew? Of course not. Task.Factory.StartNew is a little bit complex because it has a lot of configurations. It provides us to configure our task, schedule configuration, creation option configuration, etc. We have tons of configurations, and sometimes it is really hard for us to configure the task, and in most cases we are using by default some sort of configuration, and for not to every time copy this configuration along the project, we have Task.Run. You may think that in one case Task.Run is a syntactic sugar over Task.Factory.StartNew, but in the other case it has more interesting stuff rather than Task.Factory.StartNew. So let's dive in. When you use Task.Run, it is usage approximately same as Task.Factory.StartNew. Let me just call Task.Factory.StartNew and let's go to the definition. When you go to the definition, as you can see, we have a lot of overload versions for this method. Let's see, you see we have the cancellation token, task creation options, I don't know, task scheduler, but for most applications we are using this type of configuration. Let me show you. This is going to be our action here. Okay, we have cancellation token. We are just passing it cancellation token null. For the task creation option, I will use for most cases deny child attach, and for the task scheduler we'll use a default scheduler. So you see, we have this type of default configuration for approximately most of the cases. Instead of using Task.Factory.StartNew, we have just should use Task.Run, and that's all. Cool. So this syntax here is completely equal to this syntax. So you may think that the Task.Run in this case is a syntactic sugar, is a wrapper over Task.Factory.StartNew. But that's not all. Task.Run has more abilities than being a wrapper over Task.Factory.StartNew. Let's check it. Let me show you one simple example here. I'm just going to comment this out and paste it here. So we have the Task.Run. I will use Task.Factory.StartNew. I'll not return a response. This is going to be var or task. Doesn't matter. Let's use a task. And as you know, it is possible for us to create a task that consists from multiple subtasks. Okay, so I'm just using Task.Factory.StartNew. This is dealing with decimal. Okay, this is just an example. It doesn't matter. I'm just going to use non-blocking asynchronous operation, let's say, and this is returning a 300. Cool. Let's check the type. When you use Task.Factory.StartNew with this type of implementation, when there is another task inside our task, this is our inner task, okay? And we are returning this inner task. Let's check our process bit. This is our process bitmap is our task. So let's make it var and return this, okay? Let's check the process type. Again, it is task decimal. In this case, in Microsoft, we have unwrap method that helps us to unwrap this functionality. So it will remove the wrapper task here, and you will get task decimal rather than task decimal. Okay? For this one, it is really easy for me to use Task.Run to get task decimal rather than task decimal. So in this case, Task.Run by default under the hood is going to use unwrap, okay, for the Task.Factory.StartNew. The other option here is when you are dealing with asynchronous delegates. Let me just copy this, comment it, paste it here. We have asynchronous delegate here. I'm just going to remove this, paste it here, awaitable, and let's return 300. Okay, and let's check the type. This is again task int. Why? Because when you are dealing with an asynchronous delegates in C# under the hood, we are wrapping it to a task. Okay, then you should need to use unwrap again to unwrap this functionality. This is going to be now task int. But when you use task.run, it is automatically unwraps your functionality. So you are getting task integer. At the end, let's combine what we learned in this tutorial. We talked about the differences between new task and Task.Factory.StartNew. We learned that Task.Factory.StartNew is more effective. Task.Factory.StartNew is one-step operation. For the new task, you need to construct it and then start it. For the Task.Factory.StartNew, we are doing both in one operation. And for the Task.Factory.StartNew, we don't need to deal with synchronization context. The new task is also option for us when we are inheriting from the task and when we have special type of race condition, like in the task body, we are reaching to continue with method of the given instance. We also talked about Task.Factory.StartNew and Task.Run. We learned that Task.Run is a little bit syntactical sugar over the Task.Factory.StartNew. Task.Factory.StartNew is a little bit complex. It has a lot of configuration, and Task.Run makes us to call the task creation process to run a CPU-based operation without more configuration, okay? And also Task.Factory.StartNew has the wrapping task mechanism, and using Task.Run, we are unwrapping it automatically.